Okay, so this week we're going to look at unit circle trig. We'll split it into 3 parts, and it's all in section 2.2 in your book. Okay, and the main idea with unit circle trig, I can explain it just by drawing this diagram. So what I've drawn is an x and a y axis, and I drew a circle with its center at the origin. And the circle also has a radius of 1 unit. And having a circle with a radius of 1 unit, that's what makes this a unit circle. That's all a unit circle is. It's a circle that has a radius of 1 unit. Or you could say diameter of 2. But usually we say radius of 1. Okay, and going around the circle, I've labeled 4 angles. I could label more, but these are 4 common ones we work with. 0 starting on the positive x-axis, and then going counterclockwise, 90 on the positive y, 180 on the negative x, and 270 on the negative y. And if you go all the way around, how many degrees is it to go all the way around the circle? 360. So 0 is the same as 360. Usually we call it one or the other. And I'm going to come back to the diagram in a second. So the idea with this diagram is that every angle that we're going to work with can be represented as a coordinate. That's the whole idea. Okay, so generally the angles we're going to work with are angles that are multiples of 30, like 30, 60, 90, 120, 150, things like that. And we're also going to work with angles that are multiples of 45, 45, 90, 135, 180, 225, things like that. And of course, there's some overlap there as well. But any angle that's a multiple of 30 or 45 can be represented as a coordinate on this unit circle. So let's start with the 4 that I have labeled, okay, since these coordinates are the easiest ones to come up with. Let's start with this point. Okay, that point represents 0 degrees. Anybody think they can tell me the coordinate for that point? Keep in mind, you're on a circle with a radius of 1. So you're only moving 1 unit to get to the edge of the circle. Yeah, Jamel?
1, 0.
Yeah. This is the coordinate 1, 0. Right 1, don't go up and down. And that's always the coordinate for 0 degrees. That never changes. Okay? The coordinate on the unit circle. Okay, let's do the coordinate for 90. Yeah, Gabe?
0, 1.
Yeah. Don't go left and right, just go up 1. That's always the coordinate for 90 degrees on the unit circle. Okay, how about 180? Yep, Miles?
-1, 0.
To get to 180, you just go left 1, you don't go up and down at all. And lastly, the coordinate for 270. Yep, okay. So we don't go left and right, we just go down 1. Okay, so any questions on that? So those are the 4 easiest angles to find the coordinates for, because first of all, the numbers are nice. There's no decimals or fractions. And one of the numbers in every coordinate is always a 0. Any questions on how we did that? All right, now as we move around the circle and we measure angles, there's 2 directions we can move. Okay, what are the 2 directions you can move if you're moving on a circle? We don't really say left, right, up, and down on a circle. Right?
Counterclockwise and clockwise.
Right, counterclockwise and clockwise. Does anybody remember the difference when you're measuring an angle? What's the difference between going counterclockwise or clockwise? It just changes one thing about the angle. Yeah. Yeah. So if you go counterclockwise, you're measuring a positive angle. And I think I had a diagram or a thing on the board where I could kind of drag around and make different angles. We did that last time. But if you go counterclockwise, it's positive. Clockwise is negative. Now, sometimes they might ask us a question about one of the angles I just mentioned, but it might kind of hide the fact we're talking about one of those angles. For example, if I asked you for the coordinates for 450 degrees, 450 degrees is really one of those four angles. Does anybody know which one of those four angles 450 degrees is? Yeah, it's the same as 90. And how'd you figure that out?
It's just 90 plus 360, and 360 is the same as 0. So.
Yeah, so it's like you've gone around once, that's 360, and then you went 90 more to get to 450. We don't really care how many times we go around the circle. All we care about is where do we stop. Right? So arithmetic-wise, what can you do to the number 450 to turn it into 90? Because they're the same thing. But we'd like to come up with a kind of a formula in our head to take big numbers and make them smaller. So what can you do to 450 to turn it into 90? It doesn't involve division. It is arithmetic, but not division. Yep.
Subtract it from 360.
Yeah, subtract 360. So if you have an angle that's too big, okay, and by too big I mean it's bigger than 360, generally you want to make that angle smaller. You want to make it easier to work with. So to make an angle that's bigger than 360, smaller, keep subtracting 360 until your answer is between 0 and 360. So if I was working with, let's say, I don't know, a 1,000 degree angle, and I wanted to simplify that, okay, to figure out the coordinates, I would look at that and say, well, you've gone around extra times, so let's subtract the extra times. And I would say 1,000 degrees is exactly the same as 280. And then I'd have to figure out the coordinates for that. But 280 is an easier number to work with than 1,000. Now, what do you think you could do if you were working with a negative angle? Like, let's say I gave you an angle of negative 315. And I asked you to find the coordinate. Well, negative can be a little hard to think about, so we can make it positive by doing something to it. Do you know? Yeah, you can take a negative angle, like negative 45, and you can add 360. And now I know negative 45 is the same as 315. Or if I said, what did I say, negative 315? I don't remember what I said. If you asked me to work with this angle, I would add 360 to it. It's the same as working with that angle. Okay, so you can add or subtract 360 as many times as you want. The goal is to get an angle between 0 and 360. That's the easiest way to figure out the coordinate. Now, adding or subtracting 360, that assumes that you're working with angles in what units? Think about what is 360? Jocelyn? That's in degrees. If you want to work in radians, what is 360 the same as? Remember that? 360 was the same, yeah? Is the same as 2 pi. So if you decide to work in radians, you could add or subtract 2 pi. Most people, when I teach this, they don't like to work in radians. If they have a problem in radians, they'll change it to degrees and do it that way. And that's fine too. You just have to remember how to change radians to degrees. Okay, so any questions on that idea? All right, so now what we're going to do, and you've probably seen these before, but this is the first time we've seen them in this class, is I'm going to define the 6 trig functions. And I'm going to define them in terms of what we're learning, a unit circle. So if you've done opposite, adjacent, and hypotenuse, if you've done that kind of stuff, that's not exactly what I'm doing here. Okay, it's actually the same thing, really, but it's going to be worded a little differently. Does anybody know one of the 6 functions that we use in trig? Yep. Sine. Yeah, that's one of them. Well, 6 basic ones. There's other ones, but these are the basics. Cosine. Yeah. Tangent. So those are the 3 real basic ones, sine, cosine, tangent. And then there's 3 other ones that are still basic but not used as much. Does anybody know the other 3? Well, Graham, do you remember one of them? Besides sine, cosine, and tangent.
Cotangent.
Yep, cotangent. That's one of them. Anybody know the other 2? No? All right, well, we'll get to the other 2 in a second. So all the definitions I'm going to give you are based on you being able to figure out the coordinate. None of these definitions are going to work if you can't figure out the coordinate for the angle they're asking you about. Okay, so step 1, anytime you do a unit circle trig problem, you have to find the coordinate. Then step 2, once you have the coordinate, you're going to fill into one of the 6 trig functions I'm going to put on the board. All right, so let's say they're asking you just a specific problem, the sine of 90 degrees. Step 1 would be to figure out the coordinate for 90 degrees. Okay, it's 0, 1. Then once you know the coordinate, the answer to any sine problem is just the y value. You actually don't need the x value to figure out the sine. Okay, so if I said the coordinate for 90 degrees is 0, 1, bless you, what's the y value in this coordinate? What's the y value in this coordinate? 1. So if you wanted to know the sine of 90 degrees, all you have to know is the y value of the coordinate. So the sine of 90 degrees is 1. If you wanted to know the cosine of an angle, all you need is the x value of the coordinate. Okay, so the cosine is the x value of the coordinate. And then if you want the tangent, you need both. Okay, so to find the tangent of something, you find its coordinate, take the y value, and divide by the x value. Okay, so those are the 3 basic trig functions. The next 3, we use them, but we don't use them as much. Cosecant, secant, and cotangent. Okay, what I'll do is let me put the abbreviations. So if you're using your calculator or you see them in the book, you'll know what the abbreviations are. Does anybody know the abbreviation for sine? Miles? Yeah, SIN. Sine. How about cosine? Do you know? COS. And the abbreviation for tangent? Yeah, tan. TAN. It's pretty much just the first 3 letters, but we run into a problem with cosecant. We can't do that because we already use COS. So, does anyone know how we abbreviate cosecant? Yeah? We are going to talk about that, but not. We actually won't even get to that this week. So when you put a -1, that's something else, but that is something important. Anyone have another guess how we abbreviate that? They pretty much go by the syllables. Cosecant. And then the rest you can just go back to using the first three letters. Secant and cotangent. Now, the three formulas on the right, I put them arranged the way I did because cosecant has something to do with sine. Does anybody know the formula for cosecant? Well, I'll give you a hint. The relationship between sine and cosecant, they're reciprocals. So what does it mean if something's a reciprocal? Like if I said to you that I have the fraction 2/3, tell me the reciprocal. What does that mean? That? 3/2. So what did you do? You flipped it. That's what you do. Now here we don't really have a fraction, but you can pretend. You can pretend that there's kind of an invisible 1 underneath it. So knowing that cosecant is the reciprocal of sine, what do you think cosecant is? Yeah.
1 over y.
Yeah, it's 1 over y. It's just the sign flipped. Okay, and how about the secant? Kelsey, what do you think the secant will be?
1 over
Yeah, 1 over x. The secant is just the cosine flipped. Again, if you want to pretend like it's over 1, you can. And James, what about the cotangent?
That'd be x over y.
Yeah, the cotangent is the tangent flipped. So again, the relationship between these are called reciprocals. You flip one to get the other. Okay, any questions on that? All right. So the next thing, these four angles that I named, 0, 90, 180, and 270. Okay. Where are all those points? They're all kind of in a special spot in this diagram, or they're on something special. What are all those points on? That?
The xy axis.
They're on an axis. And what do the axes do? They kind of separate, well, they separated the space into 4 sections. Does anybody know what we call those 4 sections? Yeah, Josh?
Quadrants.
Quadrants. So the axes separate the plane into 4 quadrants. And because those angles are right on the axes, we call them quadrantal angles. Because they're all on the boundary line between quadrants. So if you're reading directions on a test or something like that, and it references quadrantal angles, it means they're talking about 0, 90, 180, or 270. All right, so we know the definitions of the 6 trig functions based on a coordinate. We know the names of these angles, but we still really don't. We still got to kind of put that together. How do we actually do unit circle trig? Yeah, those 2 steps. Okay, so what I'm going to do is I'm going to ask you a problem. I'll just show you what a problem looks like. Okay. I could start you off with a coordinate and ask you to find all 6 trig functions, or I could start you off with an angle and ask you to find all 6 trig functions. Okay, I'll either start you off with one of the 2. It's actually easier when you start with an angle, with a coordinate. So step 1 is to find the point on the unit circle. Okay, find your coordinate. Sometimes, like in the first couple problems I'm going to do with you right now, sometimes I will give you the point. If I give you the point, then step 1 is done for you. Okay, so that's step one. Find the point on the unit circle. Now, as of right now, you guys really only know how to find the coordinates for 4 angles. 0, 90, 180, 270. If it's something other than those, we'll have to talk about that, but we'll probably get to that tomorrow. Okay, so once you find the coordinate, if it's not given to you, take the x and y values from your coordinate and take those x and y values and plug them into all 6 of these formulas. Sine, cosine, tangent, cosecant, secant, cotangent. You only have to plug them into all 6 if the problem asks you to. Sometimes the problem will only ask you to plug into 3 of them. But the first few problems we're going to do, they're going to have us take the coordinate and plug it into all 6 formulas. So any questions on the 2 steps? Okay, so summarized, first step, find the coordinate. Second step, plug it into the definitions. And a lot of times the coordinates we work with are going to look something like that. Okay, they're going to have square roots in them. So keep in mind the rules with square roots. Okay, what are you never allowed to do with a square root if it's your final answer? Jackie?
Yeah, that's bottom.
Right, we can't leave it in the bottom. So if for some reason we end up with a square root in the bottom somehow, we need to fix that. And if you end up with a square root of something like that, you can reduce it. Make sure you reduce it. Okay, so keep in mind, we looked at both those last week, those properties with square roots. All right, so this problem, they are starting me off with the coordinate. So step 1 is already done. The point is -1/2 square root 3/2. And if you wanted to know what is this as a decimal, it's about -0.5, 0.87. Okay, we're not using decimals really, but if you wanted to know, that's what it is. So this coordinate represents an angle. What angle does it represent? We don't know. We're never going to know. Okay? That's not the goal of this problem. The goal is to figure out not the angle, but the sine of the angle. Okay? The cosine of the angle, the tangent, and so on. So we're going to find all 6 things about the angle. Just by knowing its coordinate. All right, so let's start with sine. Sine and cosine are the easiest 2 because you really don't have to do any arithmetic at all. Okay, Michael, what was the definition for sine?
It equals y.
It equals y. And what's my y value in example 1?
The square root of 3/2?
Yep, square root 3/2. And that's it. That's the sine. Okay, we'll go through and do all 6. Kristen, what's the definition for cosine?
X.
It's the x. And what's the x in my problem?
-1/2.
-1/2. That's the cosine. Okay, Marcos, the next one is the tangent. And what's the formula for tangent?
Y over X.
It's y over x. So basically what I do a lot of times just to visualize it, it's almost like putting a division line in right here and dividing those 2. That's y, that's x. Divide them, and that's the answer for tangent. Now, when we divide 2 things with the same denominator, two fractions with the same denominator, what happens to the denominator? Well, let's think of it a different way. When you divide two fractions, usually you multiply by what? The reciprocal. Right? So instead of dividing these two fractions, let's multiply by the reciprocal of what's in the bottom. Okay. Gabe, what's the reciprocal of the fraction in the bottom?
2 over -1.
Yeah, it's 2. It doesn't matter where you put the negative. You can put it in the top or the bottom. And now, what happens to the 2's there? They cancel out. Okay, so that's what I was trying to get at earlier. When you divide two fractions with the same denominator, all you have to do is cancel the 2. Okay, I'm not going to put a line through it because those are answers to other parts of the question. Okay, but the 2's cancel out, and I'm left with negative square root 3. You could put over 1, but you don't need to. And that's it. Those are the first 3. Now, once you have the first 3, all you have to do is take each one of these and do something to get the next 3. Does anybody remember what you have to do with each one of these? Yeah, find the reciprocal. Take each one and flip it. Right, so David, what do I get if I find the reciprocal of sine?
You get 2 over square root 3.
Yep, I get 2 over square root 3. Now, numerically, that is correct, but there's a problem with leaving it like that because we have the root in the bottom. Okay, so how do we fix the root in the bottom? Miles?
Multiply the numerator and denominator by square root 3.
Yep, and can you tell me what I would get when I do that?
Just 2 square roots of 3.
2 square roots of 3. Still a denominator, though.
Over. Oh, over 3.
Yes. The square root of 3 times the square root of 3 is the square root of 9, or 3. Okay, so any question on how we got 2 over the square root of 3 to start with? Where that came from? And then any question on how we fixed it so the root wasn't in the bottom? Okay, so you have to do that on any time you get a root in the bottom. Secant, that's going to be a nice answer. We're not going to have to fix any root there because the original problem that we're going to flip doesn't have a root. Sydney, can you tell me what I get for my secant?
2 over
Yeah, 2 over negative 1. And what do you get if you take 2 divided by negative 1? Yeah, just negative 2. Okay, and the last one, we need to flip tangent, but we don't have a denominator. So what can I always put as a denominator if I want? Do you know? Yeah, you could always put a 1. Okay, so Kylie, what do I get if I flip tangent?
1 over square root of 3.
Close.
So I would get C.
Just one thing you got to be careful of.
Oh, negative.
The negative. All right, so we just make sure when we flip it, we keep the negative. All right, so we get negative 1 over the square root of 3. And once I fix that, can someone tell me what my final answer would be with the root moved to the top? Jackie?
Negative square root of 3.
Yeah. And that's it. So this would be 6 separate problems on a test. Okay, I wouldn't ask you to do all 6 in the same problem.
Did you get cotangent?
Cotangent, we just take the tangent and flip it. And again, it doesn't matter where you put the negative. I always keep negatives in the top of a fraction. Doesn't matter. Okay, and all this time, we never actually found this angle. We have no idea what this angle is. We know a lot of things about it. We know the tangent of it. We know the cosine of it. We know 6 things about it, but we don't know the angle. Okay? That's kind of like if you met someone on the street and you don't know their name, but you describe 6 things about them. Okay? You don't need to know somebody's name to describe what color shirt they're wearing, what color shoes, how tall they are. You don't need to know their name to do any of that. So it's the same idea here. You don't need to know the size or the name of this angle to describe things about it. Okay? Could we find this angle? Yes. We don't know how yet, but we could figure out exactly what this angle is. But that's not what we're doing today. Good. Any questions on that? All right, so here's another one. They're asking us to find all 6 trig functions. And again, they've started me off with the coordinate, so I don't need to find it. Now, this is unrelated to the question we're answering, but does anybody think they know what angle this coordinate represents? The x value and the y value are the same. So it's like you've gone right on the x-axis and up on the y-axis the same amount, over and up. And if you think about, here's your circle, you've gone over and up the same amount. So think about this side and that side being exactly the same. You can make a triangle if you want. Yeah? It is. We don't need to know that, but this is the coordinate for a 45-degree angle because you go over and up the same amount. Okay. So eventually, tomorrow, I'll say something like find the sine of 45 degrees, and the first step is going to be figuring this coordinate out. So tomorrow, I'll show you where these square root numbers come from. But for today, I gave it to you, so you don't have to worry about where it comes from. All right, so let's start with the sine of our angle. About Ariel, can you remind us again, what's the definition of sine? It's the y value. And, well, I know the y value is root 2 over 2, but is it the first one or the second one? Yeah, it's the second one. In this case, if you mixed up the x and the y value, you wouldn't get it wrong because they're the same, but in general, that's not true. So try not to mix those up. Okay, Gabe, what's the definition of cosine?
X value.
X value, which is also square root 2 over 2. And Becky, what's my tangent?
Y over X.
It's y over x. If you look at y and you look at x, what do you notice about y and x? They're the same. So what do you get when you divide y by x? 1. When you divide 2 things that are the same, you get 1. Now, I'm not doing it in order, but just because it's easy, what's the cotangent going to be? 1. If you take the number 1 and flip it, 1 over 1, it's still 1 over 1. There's 2 numbers you can flip and they don't change. This is one of them. Okay, if you flip 1, it stays 1. Next, my cosecant. Graham, what would my cosecant be? And you don't have to fix it for the final answer. If you get a root in the bottom, that's okay. Just leave it. For which one? Can you say it one more time? That's cotangent. So we got x over y. Can you help them out, Miles?
2 squared to 2 over 2.
Yeah, that would be almost the final answer. But first thing you want to do is just take the sine value and flip it. Remember, 1 over something just means take this and flip it. So just start with that. That's it, 2 over the square root of 2. And now we need to fix it And Miles, how did you fix that? What did you do?
Multiply the numerator and denominator by 2 squares, or 2.
Yep, just the square root of 2. And you get 2 square roots of 2 over 2. And I said that's almost the final answer because you can actually do one other thing with that. It's just the square root of 2. Because you have a 2 outside the root in the top and a 2 that's outside a root in the bottom, there's no root at all, they cancel each other out, and it's just square root of 2. Now the secant we shouldn't really have to think too hard about. What's the secant? It's the same thing. Since sine and cosine were the same, cosecant and secant are the same. And again, that would be 6 separate problems on a test. Any questions on that? Right. Let's see. Why don't you take a few minutes and try that one? Okay, so we'll do one more of this type, and then we'll switch gears and try one where they don't give you the coordinate first. Okay, but see if you can find all 6 trig functions for that coordinate. Okay, so the first 2 should be pretty quick because you just get them by looking at the coordinate. Just don't mix up which one is which. So let's start with the sine. Anybody get the sine, right?
2 square roots of 2 over 3.
Yep, 2 square root 2 over 3. Okay, how about the cosine? Yep, negative 1/3. And now for tangent, again, what I do is kind of a visual. Tangent is y divided by x.
Yeah.
Did somebody mix it?
Other way around, sine is.
Yes, thank you. So sine is negative 1/3, and the other one's 2 over 3. I said don't mix them up. Don't mix them up. Now, same thing, just divide them. And what happens when you divide those fractions, so we don't have to go through the reciprocal thing?
Negative 2 square roots of 2. Oh, I don't know.
So we might have to fix it, but what's at least going to happen first when you divide those two things? Do you know? The 3's are going to cancel, okay? Because you have the same denominator when you divide fractions, the 3's cancel. So you have negative 1 divided by 2 square root 2. And now we have to fix that by multiplying top and bottom by, yeah?
Square root of 2.
Yep, just the square root of 2. Sometimes people multiply top and bottom by 2 square root 2. That's a little too much. You just need the square root. Okay, so our final answer, let's see, we're going to get negative square root of 2 divided by, what's the square root of 2 times the square root of 2? 2 times another 2, 4. Right, so there's your tangent. Cosecant. Wendy, what do you get for the cosecant? Yep. That one's easy to flip because you don't have any roots. The cosine, okay, we're going to flip it. But what ends up happening is pretty much the same thing that happened with tangent. Okay, we get a root in the bottom. So can anybody tell me what I get when I fix that so the root's not in the bottom? Yep,
3 square roots of 2 over 4.
perfect. Okay, and the last one, the cotangent, you get a choice what you could flip here. Okay. We started with this, okay, and that answer was correct, except we didn't want to leave the root in the bottom. So you could either flip, I don't want to circle it, but you could either flip this, or you could flip what I circled. Which one is easier to flip? Yeah? Yeah. If you flip that one, then the root is going to go to the top and you're done in one step. If you flip the final answer, then what's going to happen is the root 2 is going to go back to the bottom, and then you're going to have to fix it again, and you're just going to end up getting negative 2 root 2. Okay, so sometimes some of the work that you did to get to the final answer can actually be helpful later on. Good. Any questions on those 6? So that one had a lot of arithmetic with roots. All right, what's a little different about this problem? This is the first one we've seen of this type. What have they given me here? They've given me the angle. Now the angle's fine, but that's not really helpful at all. What is it that I need to know about the angle? I need the coordinate. Okay, so if I can't figure out the coordinate for 90, I'm not going to be able to do any of these. Okay, so what I usually do, if I don't remember it, draw your diagram. Put 90. Okay, hopefully putting it in the right spot will kind of jog your memory of what the coordinate should be. Okay, so Riley, what's the coordinate for 90 degrees?
0, 1.
Yep, 0, 1. Now this problem is just like the last 3. We've got the coordinate, and there's no roots in it. So hopefully the answers here should be a little easier to do. Right, Henley, what's the sign of 90 going to be? Yeah, it's the y value, which in this case is 1. Okay, Jocelyn, how about the cosine?
That would be 0.
Yep, it's the x value, which in this case is 0. And now the tangent is the y divided by the x. 1 divided by 0. What's 1 divided by 0? Undefined. You can't do that. So for that one, you just write undefined. Okay, let's see. How about cosecant of 90? 1. Remember, if you want to make it a fraction, you could always make it 1 over 1. Same thing here. You could make it 0 over 1. What do you get if you flip 0 over 1? You get 1 over 0, which we just said earlier is undefined. So when you flip 0, you get undefined. How about when you flip undefined? What would you get? Yeah, you would get 0. Because you're taking 1 divided by 0 and you're making it 0 divided by 1, which you can do. 0 divided by 1 is 0. Okay, so anytime you're working with a quadrantal angle, these are what your answers are going to look like. 1s, 0s, maybe some negative 1s, and undefined. You'll never get anything other than the 4 things I just said when you're working with a quadrantal angle. Okay. Any questions on that? All right. This time, the directions say only find the sine, the cosine, and the tangent. You don't need to do all 6. Okay, what's a little different about this one? Yep.
It's in radians.
It's in radians. So you have 2 choices. One, either work with it in radians, or we could change it to degrees. Okay. Gabe, how do you want to do it? Do you want to work with it in radians, or do you just want to change it to degrees?
Change it to degrees.
Yeah, that's usually a good idea. Let's change it to degrees. So can somebody remind me from last week, how do I change radians to degrees? And I think, well, we did this the other way with the test problem that I went over. Yep.
Times 180 divided by pi.
Yeah, multiply by 180, divide by pi, and I get 3 times 180, or just think in your head, 3 times 18, and add a 0. So what's 3 times 180? Or if we need a calculator, we can use that, but yeah, it's fine. So now I'm asking you for the sine, the cosine, and the tangent of 540 degrees. That's better than maybe working in radians, but I still don't like that. What do you think I'm thinking is still difficult with this? Yeah?
It's too big.
It's too big. So we have a way to make it smaller. What can we do to make it smaller, Gladys?
Subtract 360.
Yeah. Take the angle, subtract 360, and we get 180. So now I'm hoping people recognize 180 and they know the coordinate for 180. Hey, what's my coordinate for 180, which is really the same coordinate as 3 pi? Yep,
Negative 1, 0.
that's it. So now we've got the coordinate. Now go through and just do the 3 that it asks for. Kylie, what would be the sine of 3 pi?
0.
Let's see, the y value, which would be 0. Yep. David, how about the cosine? Yep, it's the x value. And tangent, just take the 2 that you just wrote and divide them. What's 0 divided by negative 1? Marcus? No. 0. Remember, when you have a number and you try to divide by 0, it spells no. That's when you can't do it. Okay? Number divided by 0, you can't do. 0 divided by a number spells on. So you can do that. Number divided by 0 spells no. And for this one, let's just do the 3. Okay, so find the sine, the cosine, and the tangent again. Okay, so this time I'm not going to say anything. I'm just going to ask for some advice. What should I do first here? Yep, change the degrees. How do I do that? All right, so pi's are gone. I can cancel the 2 into 180. And what's 11 times 90? 990. If you don't like working in radians, then that's better because now you have it in degrees, but still not the best option here. What can I do with 990? Yep.
Subtract 360.
Yep, and I can probably do it a second time. So I'm going to take 990, subtract twice. If you accidentally go too far and it becomes negative, then add 360 back to it. 270. Okay, so now I've got my angle and I've got it small enough I can work with it. What do I need to figure out now? I need the coordinate. Where's 270 on that circle? Jim out?
0,
Oh, it's right there. 0, negative 1. Now I have the information I need to answer those 3 questions. So Sydney, what is the sine? Yep, negative 1. About James, what's the cosine?
It'd be 0.
0. And Marcos, what's the tangent? Undefined, good. Okay, so any questions on that? So all the coordinates, if they don't give them to you, are either going to come out to 0, 90, 180, or 270 tonight. Tomorrow we'll talk about what happens when it's not one of those 4 I just said. Okay, so the homework, it's on 116. It's 11 to 27 odd, and the only even one is 22. So do 22 as well. Okay, so we'll take a look at that tomorrow. Even though we had the snow day, I'm still planning on staying after school on Thursday if anybody needs extra help. and we'll have our test on Friday.
Well, back a slide real quick.